Hello everyone, welcome to my YouTube channel. It's Max, and today I wanted to show you guys just like a simple project about how to draw a Sierpinski triangle using the Chaos game. So first things first, let's just go over what a Sierpinski triangle is really quick. Let's go to Chrome. And so here's a good picture of what a Sierpinski triangle is. Basically you just have a triangle, and then you sort of like an equilateral triangle, and you sort of cut out the upside down like middle inner equilateral triangle, and then you get sort of this shape, and then you just keep repeating that process over and over again, and you keep getting these smaller and smaller triangles, and you get this nice fractal pattern. And yeah, for a long time I didn't actually know what a Sierpinski triangle was, but I've sort of been exposed to this shape very early on in the form of Zelda and the Triforce. I think that's where a lot of people I know actually have first seen this shape. And so the way we're going to be creating this fractal is using what's called the Chaos game. And so the Chaos game is a way of kind of randomly picking points in a special way that can generate different kinds of fractals. So for example, like here's a fractal you can generate using the Chaos game, and then these are three other versions, but depending on what sort of polygon you start with and then how you generate the points, you can get different fractal patterns. But for the purpose of this video, we're just going to focus on getting the Sierpinski triangle right here. And before we start coding that up, let's just go over how the algorithm is actually going to work. So I'm just going to open a PowerPoint and just go over a brief visualization of the algorithm. Let's get rid of this stuff. Okay, so it starts off with, we're going to have an equilateral triangle. And we don't want to fill in here. And we don't actually have like a full triangle with actual like full edges, but you can just imagine we have 3 points that constitute an equilateral triangle. And then we're going to randomly pick a point somewhere. And the point actually doesn't even have to land in the equilateral triangle. If it lands outside, you might have like a weird looking point at the end, but that's still okay. So let's say we have some random point right here. Okay, so once we have this random point, we're going to randomly pick one of the 3 vertices of the triangle. So let's say when we randomly pick a vertex, we get a new point. Like we get one, oh no. Like let's say we get the bottom left. If I can pick up this small thing. There we go. Okay, so once we randomly pick a one of the random vertices, we take the point we started with and the random vertex we picked. We draw a line from one to the other, and then we select the midpoint, and that midpoint will be the new point in the final drawing. So you can imagine like the line is just an illustration, but once we pick the midpoint, this line goes away, and now we have these 2 points drawn. And I just put this point here as an illustration, but we don't actually have this point, this vertex drawn. And then starting from this point, you would randomly pick another vertex and then repeat that process. And if you did this over and over and over again, you would end up getting a pattern that looks like the Sierpinski triangle we just saw. So with that sort of brief introduction of the algorithm, let's code it up in Python. So like any sort of, mathematical drawing stuff, we're going to basically be working mostly with NumPy and Matplotlib. np import matplotlib.pyplot as plot. And we'll just call this Sierpinski triangle. Sierpinski triangle. Okay, so there's 2 main parameters that are going to define what this triangle looks like. Or I guess there's really only one, and it's just going to be like how many points we decide to draw. So we're going to just call that value n, and let's say we'll start off with 1,000. And I was going to say there's a second value, which is like the side lengths of the triangles, but that's not really going to matter in the end. So for simplicity, we'll just say the side lengths are 1. Okay, so the next thing we need to do is define the vertices of our triangle. And so let's just start with the lower left, and we'll call it A. So, and we'll just define that coordinate as 0, 0. The next vertice, we'll call it B. It'll be the lower right, and so that'll be, we'll call it just L and 0 height. Oops. The last vertice will be the upper one, which is C, and that'll have an x-coordinate of L over 2, because it's in between A and B, and it will have a height of square root of 3 times L over 2, and then that's just the height of an equilateral triangle. Okay, so we've got how many points we're going to draw. We have our vertices defined. Now the next thing we need to do is just randomly pick a point in our space. So let's just do that, and we'll call the two coordinates we pick sort of our current x value and our current y value. So let's say current x equals numpy.random.rand. Just give us one value. And I multiply it by L in case like you for some reason chose the side length not to be 1. In this case it doesn't really do anything, but if it was like 1,000 it would scale it properly. Then we have our current y as np.random.rand1 times this value. And again, doesn't really matter. We can still land outside the triangle, but like I said, that's okay. Okay, we have our current x, we have our current y, and now we need to start going through one point at a time, randomly picking a vertex, and then finding the midpoint between there and drawing those lines. One last thing we need to do before we can start doing that is we just need two lists to hold our x and y coordinates. So we'll have some x data. It's just going to be some list. We'll have y data, steps list, and let's just put our first values we just made in there too. So x data dot append current x, y data dot append current y. Okay, cool. Okay, yeah, now let's implement the algorithm. So we're going to go through all of our points that, or the number of points we specified, which is 1,000. So for n in range of n. So first we need to randomly pick a vertex. So we'll say like random vertex is equal to numpy.random.rand int. And so this will randomly pick an integer between 0 and 2. And depending on which integer we get, we'll pick another vertex. So if random vertex is exactly equal to 0, then we'll just say like we'll treat that as if we picked the A coordinate as our vertex. So the new value of x will be equal to the current value of x plus the x coordinate of A divided by 2. And that's just the halfway point of the x coordinates between, or the average of the x coordinates between the current value of our starting point and the vertex we picked. And then likewise, we'll do the same thing for the y coordinate. 1, current y, or new y, and then else if. So that's the case if our vertex is 0, we basically picked the A point. If our vertex is 1, we'll pick the B point. So just change this to B. And then lastly will be if we get a 2 or something else, which we shouldn't get something else, it'll be C. Okay, cool. Lastly, now we need to add these new points to our list. So xdata.append new x, ydata.append new y, and then the last thing we need to do is reassign our variables for current x and current y with our new variable, new x and new y. So current x equals new x, current y equals new y. And that's it. We're just going to keep repeating this process over and over again, randomly picking a vertex, creating a new coordinate that's the midpoint between the last point we left off at and the randomly selected vertex we chosen, append it to a list, do that 1,000 times, and then the last thing we need to do is plot the final values. So plot x data, y data, and we're going to plot them as points instead of lines, or else it'll be a huge mess. And we actually probably want to make the markers, the dots a little smaller, so I'm going to change marker size. Marker size to like 0.5 to start, and let's see how that looks. And then plot.show. Okay, let's see if we got a triangle. Oop, something's wrong. Uh-oh, data. Okay, let's give it a shot. And we got nothing. So there's something went wrong here. All right, let's take a look. Random vertex. It looks like it's always picking like the bottom of the screen for some reason. What the heck? Okay, let's figure out why that is. I think this should always give us a number between 0 and 2. This actually needs to be between 0 and 3 because this is exclusive. Let's try it now. There we go. Okay. So yeah, we were picking numbers between 0 and 1, so we were only getting points between the A and B vertex, and then now that we can randomly pick between points 0, 1, or 2, we got the full Sierpinski triangle. And if you want this to be filled in more, you can just change the value of n. And change the value of n, rerun it, you have double the points, and it starts filling in better. And I'm going to do one last time just to like do 1,000 or 10,000. And yeah, that's a 10,000 point Sierpinski triangle. Okay, so now that we have the code that makes the triangle, you know, one way that we could make this a lot cooler is if we could actually see the points getting drawn in real time. One thing that's kind of annoying about Matplotlib is you can't just like take this line and put it in the for loop. So for example, like if I were to just do this, I would hope that, you know, it would keep drawing it would keep redrawing a plot with the new updated versions of X data and Y data, but it doesn't do that. So here's what'll happen. I'm gonna make it 1,000 points in case it like really starts to slow down. Yeah, so like as you can see, we didn't actually see the points get drawn. And I could even put a delay here too. I could say like, you know, I could import time, and I could say, what is it, like time dot sleep or something. Yeah, like let's say 1 second just for illustrative purposes. And now just like nothing's happening. Like it's running through this loop, but like it's not actually like rendering the drawing on the screen. So I kind of did some, you know, some TV internet magic off screen, but I have an animated version here. And so, yeah, I didn't actually know how to animate Matplotlib very well, and there are certain solutions that don't work in certain IDEs. So I'm using Spider right now, and the solution I found that worked was from this link in Stack Overflow, and I'll include that link in the description. But this person just showed a way about how to animate stuff and have it work in Spider, and they had a pretty object-oriented solution, so I took their solution and then just sort of ripped out all the classes and just sort of made this one update method. But basically you have to explicitly like define your plot, grab an axis, grab a figure, grab the actual line objects of the plot. But once you have all those, you can just pass them to this update. And I think the main like sort of magic of this part is updating the line objects and then doing this canvas.draw and canvas.flush events. And when you do that, you actually can put that method in a for loop, and it will it'll update the points in real time. If you want to slow it down, you can add a sleep to the end of the for loop as well. I think if you just draw it as fast as it can, it looks pretty nice. And then I just added a couple extra parameters to the plotting here, basically just making a background color, changing changing the points to yellow, and also just changing the boundaries of the like margins of the window just to for what I thought looked nice. And if we run this, now you can actually see the points get drawn one by one to create the triangle. And it's kind of funny, like if you actually make this bigger, like the points kind of draw slower than when it's a small window. And then I chose the colors because I thought they were kind of like Zelda themed, like the gold for the Triforce and dark green for kind of like the woods and Link and stuff like that. But yeah, that's that's sort of the animated version of what we just showed. And I know I went over that pretty briefly because I just sort of did this offline because I don't have a ton of experience with this kind of updating. But I'll include the link to the Stack Overflow site that discusses this in the description, and I'll also put a link to my GitHub with both of these files in there so you guys can check it out and run it yourself. Before I go, there's one more animation I want to show you guys regarding drawing a Sierpinski triangle. For those who are familiar with the YouTube channel 3 Blue 1 Brown by Grant Sanderson, it's a really awesome math YouTube channel with these really cool animations. And the thing that's super cool about Grant Sanderson is not only is he like a really good storyteller, a really good math YouTuber, he also completely made the animation engine he uses from scratch in Python, and he's open sourced that to the community. So recently I've been learning how to use that library. It's called Manum, and I want to show you guys how I used Manum to create an animation for the Sierpinski triangle. So, and the way Manum works is really cool. You describe the animations in Python, then it'll either generate an MP4 or a .gif file. And so here's one I made for this project. Here we're just explicitly coloring the 3 vertices of the triangle, randomly picking a point in the triangle, and then randomly selecting a vertex between the point we selected and the vertex chosen, and just repeating that process with explicitly drawing the lines for more of an illustrative purpose. And yeah, the animations in Manum, they're just like really clean, really smooth, and everything just looks really polished. So I just wanted to show you guys this last animation. And with that, that's the end of the video. If you guys like this kind of content, or you want to see more stuff like this in the future, like how I made the animation in Manum, things like that, please, like, comment, subscribe, let me know. And with that, thank you for watching and have a nice day. I'll see you guys later. Bye.